Alright, so we're back. We just finished number 8. Let's take a look at 9 here. We've got a multiple choice question. Number 9, which of the following lines are examples of direct variation? So when you read that, underline the key words, direct. Now what does direct tell you? It means as a line, it needs to go through where? The origin. Has to go through the origin. So if you look at your choices here, here's the origin. Now which line is that? That looks like line A. Line B is a vertical line, but it does not go through 0, 0. Line C does not go through 0, 0. And line D is horizontal. That does not go through 0, 0. So which of the following lines are examples of direct variation? Line A. Number 10. Which equation is an example of a direct variation? Now remember, it's a line. It has to go through 0, 0. So it can't be A because the y-intercept is not 0, it's 3. How about B? The y-intercept is positive 1. No good. Now C, y equals negative 4, that's horizontal. But the horizontal line, the y-intercept, is negative 4. If you graph that, if we come back over here, y equals negative 4 looks like that. That doesn't go through 0, 0. So the last one is choice D, y equals negative 1/4 x. You could put a plus 0 there. The y-intercept is 0, goes through the origin. The answer is D. Okay, now let's do a couple more examples here. Let's recall from yesterday. If it's a direct variation, we divide. We do y divided by x, kind of like slope. Y is on top, x is on the bottom. That gives you your constant. To solve these, you can set up a proportion. Two fractions equal to each other. All right, for example, if we have y over 12 equals 4 over 8. And remember, the way you solve that, you have to cross multiply. You do y times 8, which is 8y, equals, all right, it's an equation when you do this. 8y equals 12 times 4, which is 48. How do you solve that? Divide by 8, you get y equals 6. That's how you solve for a direct variation. You can do a proportion. Now for inverse, where you're multiplying the variables, you get x times y equals k, and then you can, that's the setup for the equation. You could also set up x times y equals x times y. Now that probably doesn't make a lot of sense yet, so let me do a couple examples with you. Take a look at number 11. If y varies inversely, that's important, as x. Inverse variation, you multiply the variables. Direct, divide. Direct, divide. Inverse, multiply. Inverse, multiply. Direct, divide. Okay, I think I've made my point. So if y varies inversely as x and y equals 8 when x equals 5, find the constant of variation. So we're looking for k. Well, inverse means multiply the variables to get the constant. X times y equals k. X is 5 when y is 8. 5 times 8 equals 40. So the constant is 40. The constant of variation is 40. Now the second part of the question, it says write the equation describing the relationship. Well, for the equation, it's x times y equals the constant. X times y equals k. Now let's do one more thing. Let's solve it for y. Let's move the x. How do you move the x? That's x times y, so we're going to divide by x. And what we get is y equals 40 divided by x. That's the equation. So this is the constant. 40 is the constant of variation. Y equals 40 divided by x is the equation. That's how you answer that. Now let's flip it on to the last page and we'll do a few more examples. So let's see, we're up to number 12. And actually, this is very similar to 11, a little bit different. If y varies inversely as x, and y equals 8 when x equals 5, so those two values kind of go together, find the y value when x is 10. All right, now this is different from the last question because they give you 3 numbers. They give you one more number and they say find the 4th number, find what's missing. Well, here's how we set this up. If it was direct variation, we would do a proportion. But because it's inverse, we multiply the variables. So we're going to do, on the side here, we're going to do x times y, and we're going to do x times y. That's how we're going to set it up. Now, so the first one is y equals 8 when x is 5. 5 times 8 equals. Over here, they give you the x value, but we're missing the y. So it's x times y, that's 10 times y. Now we solve it. 5 times 8 is 40 equals 10y. 10 times y. How do you solve it? Last step, divide by 10, divide by 10. We get 4 equals y. Now, does that really work? Well, you can check it. If I do 8 times 5, I get 40. If I do 4 times 10, I get 40. That makes it true. Makes it work. Number 13. If y varies inversely as x, so we're going to be multiplying, y equals 6 when x equals 2. So 2 times 6 equals, find x when y equals 4. Now normally I put the normally I do x times y. But because, all right, x is a variable and then the y value is 4, when I multiply that, I'm going to write that as 4 times x. I could write it as x times 4, but normally we put the coefficient in front of the variable. So let's simplify. 12 equals 4 times x. How do you solve that? Divide by 4. 12 divided by 4 is 3. So 3 is equal to x. Let's skip 14. You do that one. And let's do 15. If y varies directly as x, and y equals 6 when x equals 4. So direct means divide. Y divided by x. That's how we're going to set it up. Y divided by x. So 6 divided by 4. Y equals 6 when x equals 4. Find the y when x is 28. Find the y. We don't know that when x is 28. Y divided by x equals y divided by x. Solve it. Let's cross multiply. 4 times y, 4y, equals 6 times 28. Let's see. Let me use a calculator here. 6 times 28, 6 times 28 gives me 168. 4y equals 168. One more step. Let's divide by 4, divide by 4. Y equals 42. All right, let's do one more problem here, and then I'll let you finish these. Let's look at 16. Let's look at 16. The pitch of a musical tone varies inversely as its wavelength. That's real important. That tells you how to do the problem. If one tone has a pitch of 440 vibrations per second and a wavelength of 2.4 feet, find the wavelength of a tone. Find the wavelength of a tone that has a pitch of 660 vibrations per second. Okay, wow. There's a lot of confusing words in this problem. Here's the key thing. What are we comparing? It says it's an inverse variation, and we are comparing the pitch of a musical tone and its wavelength. So I'm going to say P for the pitch, and I'm going to say W for the wavelength. P and W. And we're multiplying those. Why do we multiply? Because it's an inverse variation. So the pitch, 440 vibrations per second. has a wavelength of 2.4 feet. So pitch times wavelength, those two go together, equals pitch times wavelength. Now let's see. Find the wavelength of a tone that has a pitch of 660 vibrations per second. Now we don't know the other wavelength. They say find the wavelength. Let me call that W. Let's solve the problem now. First of all, let's simplify. Let's do 440 times 2.4. 440 times 2.4, 1056. So that's 1056 equals 660W. Now we're solving for W, so we have to undo this multiplying. Let's divide by 660. And we get W equals, we get 1056 divided by 660. We're going to get a decimal, 1.6. So the wavelength is 1.6 feet. Okay, 1.6 feet. They tell me the other wavelength was 2.4 feet, so this wavelength is 1.6 feet. Okay, so what I want you to do now, finish these last couple of problems and anything else that we have not done on the other pages.